equations. Okay, so we've talked about two different ways to solve for logs and exponentials, right? But now we're going to talk about a couple more. Okay, so the first property we've already talked about as well, right? Converting to logarithmic to exponential, and that's only one way to do it. And that was yesterday's scenario. We learned two more today. So, and that goes to the second one. And it's very similar to the one we have on top. So I'm just going to give a quick rundown of what we also have. Well, actually, I have it here, right? So we also have this third one, right? We talked about the section 4.2 is if I have the same bases, therefore the powers are going to be the same, right? So that's 4.2 stuff. 4.3 is using this rule to solve, which we just had a little example of earlier. And now the new ones are 2 and 4, okay? So 2 is the equivalency of 3 basically when it comes to logs. So if I have the log with the same base, so log with the same base, therefore what's being evaluated, meaning what's in parentheses, also can equal one another, right? It's just the same situation as what we had for 3. If I have the bases being the same, therefore the powers are the same. Same thing applies with logs. If I have the logs being the same on both sides of the equal sign, therefore inside stuff must equal to each other. Okay? And I'm going to give you guys an example of every case as well, so don't worry when it comes to it. Okay? So if you're when it comes to easiest to hardest, what you prefer is 2, 3, and 1 are all not too bad. Number 4 is going to be the horrible one, and we'll talk about that one as well. Okay, so the horrible one, or the hardest one to deal with, is what if you cannot do the first 3? That's the problem, right? There's always situations it's not perfect. So what happens when you cannot do 1, 2, or 3? Therefore, we have to come up with something new. And in order to do this new stuff, what we have to do is to take the log of both sides and use the log properties to solely simplify as best we possibly can. Okay. And again, that's going to be the most difficult because it's the most work involved. The other 3 aren't too bad itself. Okay. And now the next one I want to talk about is it's a combination of the first 3, but we also can use properties to simplify. Simplify first. Okay. What I mean by that is sometimes before you can do rule 1, 2, or 3, or even 4 sometimes, you may need to do these ones, either expand it or compress it before you can use any of these rules, okay? And actually, B and C are a good explanation of how to do that as well once we get there, okay? All right, so it's a lot of talking, so a lot of scenarios like how do we put these to play, okay? So let's just look at the first example, okay? So the first example is 3 log base 6x equals log base 6, 8. Okay. Now you may think, okay, that's not too bad. That looks like rule 2, which here be correct. The only thing is, however, we got to be careful of, notice there's no number in front of the log. Here we actually have a number. So that's what we mean by using properties to help us simplify, right? This is going backwards. So whenever you're solving for a variable using logs, you always be condensing everything to one single log. Meaning, when it comes to condensing, first thing is property 6, right? You bring it back over here using the power rule. So this is going to be log base 6 of x to the 3rd power equals log base 6 of 8. Right, just using the property we learned yesterday. Right. So let me get those out. So if you're wondering, that is property 6 here. Right, just going backwards. So from here, now we can use this one. So since they're the same base, same log, therefore we have x to the 3rd must equal 8. And that's how we use the second property there. And then that's not too bad, right? What number to the 3rd power can give you 8? And the only number that works is x must equal 2. Okay. Any questions on the first one at all? No, not too bad. Hopefully all your homework's like this. won't be too bad. I only give you little hard ones. Not too bad. Okay. So now let's look at B. So like I said earlier, right, just like the first one, sometimes you have to use the simplified properties first before you can evaluate these. And this is a good one because notice we're having adding logs together. So therefore, remember, when we add logs, that's the same thing, put them together, we're going to multiply. So when you add, condense into a multiplication. So if we condense just this side over here, it's going to be log base 2 of x plus 6 times 2. And that whole thing is going to equal 1 now. Okay. So if it's easier, we could distribute this in to make it a little easier for ourselves. Okay. All right, so now we have this. So now you think, okay, which one applies to this one, right? We don't have this, we don't have that happening, and this is a bad one. So I guess we have to do this one, right? It doesn't look like it. However, we can use the old-fashioned one to help ourselves out, the simplifying. So we can convert. So this one's going to be y, this whole thing is going to be x, and this thing is going to be a. So now when we simplify this or just convert it, right, using our equivalency, we're going to have 2 raised to the 1 power equals 2x plus 12. And look at that. It makes it much easier to simplify and solve now. And again, right, all we did was use the first property, the equivalency, right, to solve for the variable. So 2, subtract 12 to both sides, and then divide by 2. So we have x must equal -5. Any questions on this one at all? So it was comfortable trying to identify that was the first one? Okay. All right. So C is very similar. And like I said last time, natural log is the same as log. You use the same properties, same rules, all this applies. So if that all applies, therefore, we have a minus. So to put these together, our rule is when it comes to minus, we divide. So it's going to be the natural log of x plus 6 over x minus 4. All right, and believe it or not, this actually is number 2. Logs on both sides, natural log on both sides, so therefore they must equal one another. So we actually have this happening. And again, you may think, okay, this is still pretty difficult. It's actually not that bad. Again, right, when it comes to it, just time consuming. It's not really difficult to deal with. Okay. All right, so how do we solve for x here? Well, first off, we have to multiply what's on the bottom of the fraction. So those cancel. Here we distribute. Gives us this. And then remember, when it comes to solving, you bring everything to one side. So we're going to subtract x and then subtract 6 to both sides. So get a big fat 0 over here. And look at that, we have a quadratic. So we can solve however we choose, right? Factoring, quadratic formula, anything your heart desires. Now, hopefully, I was nice enough that this makes it a little easier to deal with when it comes to factoring. I'm pretty sure. The top number is going to be -6, -5. So it looks like 6 and -1 work. Yeah, there we go. So we have x plus 6 and x minus 1. So set them both equal to 0. So this time we get 2 answers. And there we go. So whenever you have a situation like this, don't stress. Just follow your order operations, right? You want to get rid of the bottom stuff, and you'll notice it slowly, nicely breaks it down for you. So any questions on like this type of scenario at all? So we're good what we just did, put them together, and then using second property to set them equal, and then slowly using algebra right to slowly break this down. And again, this always works for no matter what. So whenever you have a variable on the bottom, always do this, and it always brings it to the top, makes it much easier. Okay. All right, so D is probably you guys' favorite because it's straightforward, right? It's the ones we did the first 4.2, the exponential, same base. So therefore, we can set the powers equal to one another. And this is why it's everybody's favorite, right? It's a nice, quick subtraction. Definitely want all this on the test, right? Most of this homework like this, right? As well. So that's identifying the three scenarios there. So 1, 2, and 3 are used in these 4 examples here, right? So we used 1 in the first one. No, we used 2 in the first one. The first one, number 1 here. Number 2 here again. And then this one you use as number 3. Which means the last ones are using the worst ones, the harder properties, because I want to give you guys a little bit more practice for each individual case. Okay. So what happens when all 3 fail, when you cannot actually do that? Okay. And it's going to be like a situation like this. Okay. So if you're wondering, okay, how does it look like? When it comes to step 4, or the property 4 we're going to be using, it's always going to look like in this case. It's never going to have logs in it. It's going to have exponentials in it. Okay. And just like we did last time, right? Let's say this, if this is a 25, we can do 25 be 5 squared. So we can put the bases being the same. However, here in this case, there's no way I can, I can do something to 2 to give it 7, right? 2 squared gives you 4. 2 to the third gives you 8, right? There's no actual number to do this. So when this, this situation fails where I cannot actually physically make one equal the other, just like 5 and 3, right? There's no way I can, 3 squared is 9 already, so it's already past 5, right? I don't know the exact number that could do that. So therefore, this is when rule 4 comes into play, okay? Now, what we're going to do is you're literally going to take the log of both sides, okay? So what I mean by that is going to look like this. Just like that. So you're literally going to take the log of both sides. Now that we have this, then we're going to use properties to solve for this. So again, the major properties we know is, again, these ones. Okay. Well, when it comes to this type of portion, so it's, we want the x to be not in the power, right? So, well, we know there's a property to get rid of that, and that's property 6, right? Power goes to the front. So what I can do now here is using the property 6 of we know, we're going to bring this to the front. So now it's going to be x times log 2 equals log 7. And now remember, we want to solve for x. So we're just going to divide by log 2, log 2. And believe it or not, this is actually your answer. So in the back of the book, when you see your homework, that's exactly how the answer is going to look like. Now, the good thing is you can actually use a calculator if you really, really, really want. So I'm going to show you guys an alternative to do this. But on the quizzes and on the test, you're going to have to do it this way. But I can show you guys how that's going to work out. So If you guys want, we can start it right there. We start at this center right here. So you can show you're doing the exact same thing. You just log of a number is just a number we don't actually want to do it as a calculator wise. So if I do log of 2, it gives me that number there. So I'll just go to 0.3. So on this side, I'm going to have 0.3x, and just do the same thing on the other side. Log of 7, let's say it's 0.8. Right, so how we'd solve for x? Well, you would divide both sides by 0.3. So notice we're doing the same thing here. We're just not evaluating what that number actually is. Okay, so again, if we just evaluate it, x will equal whatever this division ends up being here. So approximately 2.7. But again, you kind of want to leave it just like this. Okay. I just want to show you guys that it's the same process, right? This is just a number. It's just a number, like assume you don't have a calculator, you don't know what it is. So you just treat it as a number. So you can divide it, multiply, add it, all that fun stuff to both sides, one side, and stuff like that. Okay. So again, if I really want to evaluate this, it'd be roughly that. Again, just using that property there. Okay. So again, before I go any further, any questions of what we just did for E? No, everybody good? Good. So if you're not really comfortable, well, don't worry. We have plenty of more examples just like that. Okay. So F, G, and H are all going to be the same template. So kind of nice, right? More repetitive kind of stuff. So for F, same process, right? There's no way I can get some power to give you 5, and there's no way 5 to some power will give you 8, right? So therefore, we do the exact same process we just did here. So we're going to take the log of both sides. And notice it's almost an identical pattern what we just did. So it's a power. So using property 6, bring it to the front. And the good thing is, when it comes to the step 4, again, it's the hardest one. A lot of it is going to be repetitive. It's just, mostly all going to be the same pattern when it comes to. I'm not going to confuse you too much. And I believe your homework doesn't confuse you like crazy as well. It's going to be roughly the same pattern over and over and over again. Okay. So then we have negative x times log of 8 equals log 5. So we're going to divide by negative log of 8. And if you wonder why negative, I just want x. I just don't want a negative x. So I'll just do the whole thing at once. So the answer is x equals negative log of 5 over log of 8. And you can keep the negative on the top or bottom. I just preferred on the top, but I'm fine either way you put it. And there you go. There's your answer.
Just a quick question. Is it because we're just following the rule number 4? We're not going to convert that negative x to a 1/8, right?
Yeah, that's the reason why. Yeah. So okay. You would actually be doing more work for yourself.
Okay.
If you did that way, yeah. Well, fun fact, you can actually do that and still get the same answer. So yeah. So when it comes to these, a lot of these you could do it in multiple ways and you'll get the same answer. The only difference is this negative will be gone and this will be 1/8 here. And believe it or not, you would actually get the same result. So pretty interesting stuff. Yeah. But try it. You actually get the same result either way. It's pretty cool. Any other questions so far? Okay. Now, the hardest of these ones is, well, what if it's not just like one quick step process, right? So I say this is like a one quick step process if I'm there. What if I have to do this to both sides? Well, what if I have to do the power rule to both sides here? And that's what's going to happen for G. Okay. So again, there's no way I can go from 3 to 5, 5 to 3, right? Some nice power. So if I take the log to both sides, Now notice here, again, yes, we're going to do the power rule, but we also have the power rule here. So now it's to both sides, not just to one single side. So this is going to be x minus 2 times log 5, and then 3x plus 2 times log of 3. All right, so maybe wondering, okay, what do I do now? And believe it or not, let's see. Yeah, believe it or not, we're going to have to distribute this in. Like that. So we're going to have x log of 5 minus 2 times log of 5. Now, this is a trick question. You're not going to be multiplying the 2 times the 5, right? It's just 2 times this number. So it's going to be 2 times that number. And same thing on the other side. Okay. Now, at this point, I'm actually glad Jonathan asked this question because this is a precursor of what we just did here. Now, at this point, we're actually right here. We want to get all of the x, all the y's on one side, because we want to solve for y here. So therefore, we do the same process here. We're going to bring all the x's to one side and everything else to the other side, meaning I'm going to bring this one here and this one there. I'm just going to swap their places. Okay. Again, just like we did earlier for this example here. Okay. And actually, I'm going to follow this exact template as well. Okay. So I'm going to have x times log 5. So if I bring it to this side, it's going to be a minus now. Equals. And if I bring it to this side, it's going to be now plus. And again, notice it's exactly the same template as we have now here. We had y's on both sides, so therefore the next step is we factored it out. Again, right, we cannot do anything on this side, so we factored out. So it's exactly what I'm going to do now here. I'm going to factor out the x. So now it's going to look like this. And then the last step is to finally divide this whole thing by both sides. So don't worry, these will actually be the longest of which be seen, because the reason why is because we had x plus something on both sides. If we just had it on one side, it wouldn't be too long, but again, you would do the exact same process either way as well. So again, you'll actually get a number. You'll get something like this if you don't use a calculator. And that whole horrible mess is your actual answer for this one. So, any questions on this one at all? How we started it and how we so slowly simplified this?
Did you change the signs because we swapped places?
Yeah, because
Okay.
technically you're subtracting this one and you're adding it. That's
Oh,
why. So I just
okay.
get that quick little step, yeah.
Okay, makes sense. Thank you.
So any other questions on this one? Everybody good so far? All right, so let's finish up with a little easier one since of that horrible mess, right? So notice these are going to be the same template as those ones, right? So there's your first extra credit of the two. Go ahead and try H out. Go for it. And again, just put it in the chat. Give you guys another quick 30 seconds to fish up. Okay. Everybody try. Looks like it. Okay. So taking the log of both sides. Using our power rule. And then dividing over, we get our answer. Good. Nice job. All right, so any questions on the different types of scenarios you'll be dealing with in this section at all, on 4.5? Nothing at all? Okay, good. I'm glad. Again, so the most difficult you'll be seeing, if you guys notice, is G, right? And it's just, the good thing is you just follow this template, right? Now, what I do want to give you guys is an extra problem, just in case. Let's suppose I'm just going to do is going to tweak G here, so you can see a little different scenario. Just a little difference, okay? That way you can notice it's almost the same template as what we did for G. Okay? So same situation, take the log of both sides. Same thing, we're going to use our power rule, just like we did here. Now notice here, we don't have to distribute, but this one we still do. So it's a little bit like half of the work you have to do here when it comes to it. So if I distribute, okay. So at this point, we had all this mess, right? But notice we just have one less term, which is a little nicer to look at. Okay? And again, you still want to bring all the x's to one side, so I can bring this one here and bring that over there. So I'm going to have this first, so x is log of 4, and this is now being minus, because I'm subtracting it, log of 5, equals, again, we're going to be adding it to the other side, it's going to be log 4. And now notice you use the exact same step that we did here. So now you're going to factor out and just divide by that whole process. So therefore, your final answer is this on top divided by that whole thing on the bottom.